Welcome to my video on iodine 131 and in particular its uses in medicine. Let's start by having a brief look at the history of iodine 131. In 1938 it was discovered by Glenn T. Siebel and John Liebinghood at the University of California. In 1946 its first use as a radioactive isotope was as a cure for thyroid cancer. In 1951 iodine 131 was the first radiopharmaceutical to be approved by the Food and Drug Administration. In 1955, it was used to diagnose liver diseases, such as viral hepatitis, and in 1982, it was the first radioactive isotope to cure malignant melanoma. Uses. Iodine 131 is one of the most used radioactive isotopes in the medicine industry today. Example of uses. Diagnostic tool for liver and kidney function abnormalities. Smaller doses of iodine 131 are used to study and treat thyroid abnormalities like cancer cells, such as this one. Larger doses are used as radiation to treat tumours in the thyroid, like this one. The production of iodine 131 has a lot of impacts on society, both negative and positive. Let's have a look at the positives. The production of iodine 131 has created many jobs all over the world. Over the years, many jobs have been created in countries such as America and Australia from the production of the isotope in universities and laboratories. Not only this, it allows researchers to develop new uses for the radioactive isotope. The production of iodine 131 has allowed researchers to constantly develop on the current therapies to reduce side effects for patients and come up with new uses for these radioactive isotopes in medicine and many other industries. But there are also negatives. External exposure to substantial amounts of the radioactive iodine can affect the people involved in the production of the isotope. This as a result causes immediate burns to the eyes and on the skin. If iodine 131 was released into the atmosphere in the form of gas as a waste product of its production, it can quickly contaminate water in dams and thus contaminate the water that humans consume. This can cause many issues on the human body, such as thyroid cancer by damaging the thyroid glands. There are many benefits to the use of iodine therapy on society. Firstly, if successful, there will be significantly reduced chances of cancer spreading throughout the body and functioning of the thyroid will return to normal. Secondly, it is a very effective treatment. It is only absorbed by the thyroid cells. This is because the thyroid cells are the only cells in the body that can absorb iodine. This allows the therapy to work effectively on only the targeted cells and cause no damage to the rest of the body. Lastly, the treatment process can be personalized to the patient, reducing side effects. People having iodine therapy will have their dosages calculated carefully in relation to their body weight and levels of cancerous cells. There are also disadvantages to the uses of iodine 131 on society. Firstly, pregnant women cannot receive the iodine treatment. This is because the radiation can have an effect on the unborn baby by harming the fetus. Brief changes to the lifestyle of the patient occurs. This usually happens for 7 days after any treatment with iodine 131 in it, and restricts patients from coming in close contact with other people, as iodine can be transferred in saliva and urine, so toilet precautions do also occur, like flushing twice and cleaning the toilet seat. Evaluation of its impacts on society. Apart from the negatives, the radioactive isotope has contributed significantly to the quality of life of patients in society. It has done this through reducing chances of cancer spreading throughout the body and acting as a diagnostic tool for many diseases. Therefore, iodine 131 has been a huge tool in the medical industry, benefiting society greatly. Impacts on the environment from the production and use. Let's start with the negatives. Radioactive iodine can enter sewage systems and rivers as a waste from its use from patients undergoing radioiodine therapies and as a waste from its production. This will contaminate aquatic environments, which greatly impacts on the species living in them by exposing the organisms to radioactive substances and contaminating their habitat, consequently altering their genetic composition. Iodine 131 can also contaminate terrestrial environments such as grass and soils through disposal in the form of gas from human activities of its use and production. The iodine gas will be absorbed by the plants through the stomatas in their leaves, and thus will affect animals that will consume these plants as their source of food, as it will be contaminated and can have a bioaccumulative effect. Now let's have a look at the positives. There are extremely low levels of radioactive iodine 131 in the general environment. Therefore, it does not pose any significant risk through human activities such as inhalation and consumption through drinking water. Also, iodine 131 does not have long residency times in the environment. This is due to its very short half-life of 8 days, and as a result, it does not pose any risks associated with its accumulation in the environment from its production. Evaluation of its impacts on the environment. Due to its short residence and current levels in the environment, the risks involved with iodine 131 are significantly reduced. In addition, there are currently strong regulations and heavy fines imposed for the incorrect handling of its use and production. Therefore, its risks are further decreased, making it a very low impact radioactive isotope on the environment. Structure of the isotope. Iodine-131 has 78 neutrons and 53 protons in the nucleus. As you can see, this means that there is a different number of protons than neutrons in the nucleus. This results in an unstable nucleus, consequently resulting in its decay because there is not enough binding energy available to hold the nucleus together due to an excess number of neutrons. How is it produced? Radioactive iodine-131 is produced artificially in nuclear reactors. This means it is man-made because it does not occur naturally. Iodine-131 is produced by nuclear fission. This is the splitting of a large atom into two or more smaller ones with the release of an energy by a nuclear reaction. The nucleus of natural isotope tellurium is bombarded with neutrons in a nuclear reactor. This results in an increased number of neutrons in the nucleus, precisely one extra. This becomes tellurium-131 with the one added neutron, which decays further to form iodine-131, and as this decays it emits gamma and beta radiation. Now, let's have a look at the chemical reactions involved in the use of the material. As iodine-131 decays, it emits radiation in the form of beta and gamma rays. That's the beta rays, and that's the gamma rays. The radioactive iodine concentrates in the thyroid gland and emits both these radiation, which kills the abnormal cells. This is because the cancer cells are more susceptible to radiation than normal cells, meaning they attract these beta and gamma radiations, killing the cells.